so many different SCMs now. You end up needing to. And other distributed source code control systems.
Okay, so as a start, I'll explain to you what I want this talk to be about. First, I want to remain really simple because Git is a tool that often frightens people, whereas it really shouldn't. And I'll try to show in many points of my talk what I do for real with Git and how I'll explain today isn't really stable yet. For now, I only use this method for my own packages without any containers. So I've started to package LLVM with Arthur. He's somewhere here, okay. And we work together using those schemes, and for now it seems to work pretty well. Ah, fuck. Okay, I'm sorry for the tool, but XPDF is doing really nasty things. Okay. So I'll start with explaining why I've chosen Git, and all my talk will be about Git, but most of it is applicable to any kind of distributed versioning system. It's not really specific to Git. Some of the tools are, though. So for starters, I've packaged in Debian big packages like KDE for a long time, something like 2 years. And my point is that it's not really interesting, not really efficient to do for many reasons. The first is that I don't always have network because I've moved my house three times in between, 2 times, and I've not had network access for many days. And with SVN, you cannot work offline. Okay, there is SVK, but I never got around it. You cannot work incrementally. What I mean is if you want to do a major change in your packaging, you have to cope with others' patches and then push all your work in one big patch, or you have to break the SVN for an unlimited amount of time, and this sucks a lot, especially if your team is the KDE one where big packages are really big, and if you lose 4 hours building your package, and that in the end it doesn't work because some random guy broke it because he uses SVN, it really sucks. Or think OpenOffice if you want. The other thing that sucks a lot with SVN is you cannot take the try and see approach. That means you don't really know where you are going, and you want to commit a lot, and then say, okay, this was not a so brilliant idea, and you want to drop everything. Well, SVN can't do that. You will put a lot of things, and then okay, it was a bad idea. You have to revert the patch, doing a new patch that unwinds the thing you committed before. It creates really ugly histories. And when you want to know what's happened for real, you have a lot of cruft in the middle, and that sucks too. And the last point is that I like to have the full upstream sources when I'm packaging unpacked. Because when you package, don't fool me, nobody writes the perfect patch the first time. You want to patch the upstream source directly, not using your patch system. And then when you have the good patch, you extract it from your upstream repository and put it in the patch system. I don't think there is, I mean, Kilt allows you to do that to some extent, but as soon as you have a big enough package, you will forget to use Kilt edit or whatever, and you end up needing to rebuild the patch, and it's quite hard. And with SVN, the point is storing a full KDE package in SVN is way too big. Each new upstream you will take too many space on the SVN server, and SVN protocol to get a new release won't be very efficient. So in KDE, for example, the KDE packaging team only versions the Debian packages, the Debian directory. The rest isn't under SVN, and it's not very practical. At least it's my opinion. And here, Git has answers for most of these problems. First, offline work is possible because it's a distributed SCM. Nothing to say more. Incremental work is possible because you commit locally, and when you have a full feature that is ready to be merged, you push it to the world, but you can really toy with it, and you don't really need to force the user to adapt to get your work before it's ready. Like I said, sometimes you want to try something. In Git, you can forget anything you did if you never shared it with anyone, because you never publish it, so it wasn't even here to start with. And then, and I will explain a few some numbers, Git storage is extremely efficient. And the thing is, the more you commit, the less a commit costs to you. Here are some numbers. I took some not so random examples. For example, the Xorg server Git repository generates a Git pack file. That's the sole thing you really need. The other things are just indexes over that pack file that take also some kind of space, but it's regenerated on your end. You don't really need to keep it. The Xorg pack file is 20 megabytes big, whereas the last tarball is 8 megabytes big, and unpacked, it's more than 80. And the Git pack file has whole history since Xorg's Git repository started back in year 2K. For dpkg, for example, the whole history since 96. It's a pack file that is smaller again than the last unpacked source. And the better example is the GNU libc. The pack file, again, is smaller than the unpacked source, and you have all history since the 80s. Though I must say, there is a little problem with that, and I explain in some words why. Git packing is very efficient because it's delta based. That means that, in fact, it takes the biggest file in the history, and every other version is expressed as what you have to remove from that file to have the older version. That way, the checkout of the recent file is really efficient because it's the head of the database chain. And removals are cheap to express because you say, okay, you start at that position and you remove that number of bytes. Whereas when you add data, you have to say, okay, at this position, I add this data, and you have to say which data it is. And this way, when you add new data, it becomes what takes the place, and the other revisions only are deltas, and deltas are really cheap. So here is the big way a new commit always is cheaper than if you did it the very same one some time ago. Okay, and the last point is that, and this is specific to Git, but most DSCM have the same tools and the same features. Git was designed by Linus to maintain the kernel, where there is something like the last estimate was for one read cycle 1,000 of contributors. It has been designed to help maintaining a source, and that means that any Git operation to look at the history is really efficient, and you have any kind of filtering you might ever want. That means, unlike using Vue CVS or any similar tools, when you want to browse the history, you can filter out files you don't care about. You can filter out even authors or committers you don't care about, and only focus on the few files you have some worries about because you think there is a regression and so on. And when you have the full history of a project, it helps a lot to tracking regressions or to backport bug fixes. Also, any Git operation to integrate patches are also very efficient and very fast. And when you want to integrate, to cherry pick some changes upstream, it's really useful. Git supports really advanced merging features. It's not specific to Git. Most DSCM do. And it's really useful because I do use Git to replace kilt in my packages, and I use Git to regenerate the patches. And it's where I gain some time because kilt doesn't have the merging features. And when you have to refresh the patches, sometimes you have to do the work by hand, where Git can help you. And well, this is a bit redundant. Okay. In other words, and that's what I just said. For me, Git is a complete toolbox, and it supersedes SVN and Kilt at the same time. And your preferred patch system. So now I'll go a bit in the details and show to you how my repositories are organized. First, there is two cases. Either my upstream has an SCM I can access to, and that Git can work. That means basically it's either Git or SVN or a simple CVS. For example, the numbers I gave you for the glibc are on the import of the glibc CVS, but it's somehow broken in the sense that tags are not at the good place, so it's unusable to work with. But the pack file is essentially the list of files that are in it, and the numbers are good. A good import will have the same size. So when my upstream has an SCM, I try to import that in Git, and all his branches are under an upstream namespace. The nice thing in Git is that you can have namespaces for your branches, and you can really, well, sort things really cleanly. If my upstreams, another problem is that often upstream read starballs that are not extracted from the SCM directly. For example, they give auto tools configures and auto configured sources, and you have a lot of cruft added. When this happens, I have a specific upstream branch that fakes the tarball, and that I try really hard to connect to the upstream branches. The reason for that is that I gain with this operation all the history of upstream connected to the Debian package. It's really important to track regressions and to see what's changed between versions. And if that doesn't happen, I just inject the tarbars in a specific branch. The examples I'll show you today are in the third category. And last but not least, I use a JOS tool, PristineTar, to save the original starballs directly in Git. That means that I don't have any file laying around when I stop working on a package. I can remove everything except the .git directory, and I have everything stored in it. I'll show an example. So it's time for a bit of demo. I hope you'll see everything. Don't hesitate to interrupt me to ask questions, because for me, what I do is really obvious, and it may not be for people not used to Git. Okay. So first, okay, the green is not really bright, but I could do that. Is that better? Okay. So the first step is to inject the source tarball. I know there is Git build packages and whatnot. I don't use it because I don't know it. And frankly, it's not really useful. So first I go in my upstream branch. I don't know if you can see it, but at the top here, okay, there is a branch of Git written in really light blue. So I'm in my upstream branch, and then I just remove everything. That's because tar is really dumb and cannot track files that disappeared. Then I unpack my new upstream. Okay, it was here. That was almost it. Okay, and now you can see all the files that changed. And I just need to commit everything. Okay, done. And like you see, Git is really fast. Okay, and now I want to remember my tarball, and here is what I do. Hop là. Let's start over. Okay. Yeah, that was almost. I can do it. Okay. And then I use PristineTar to say hello. This tarball is exactly the current state of Git. Done. And if we look at the history, and here is a marvelous tool that Git gives to us to look at the history. I'm sorry if you cannot see a lot, but what is important are the little green things on the left. Where is it? PristineTar, here. What you see is that PristineTar created a new tarball, and I can use PristineTar checkout to get my tarball back. Okay, because in PristineTar Live, it didn't choose the proper reference, and so I'm used to type it. But I think the last version does what it should. You know, when you have that in the fingers, you type it, and okay. So let's back to the talk. Let's go back to the talk. And that was just importing a new upstream. Now, second of it, I don't use Git, like I said. I have a specific branch derived from the upstream branch that I usually call suffixing plus patches to the branch I'm patching. There is many reasons to that. First, I only need to know one tool. Like I said, Git doesn't know about these three, and Git is really, really better at rebasing patches. So it gives me new features. And also, like I'll show you, I publish my branch of patches for upstreams, and I really believe it to be nicer to upstreams if they want to take patches back from my packaging. So let's see how it works. So if we look at the thing, you see here the three patches that I applied to my upstream, and upstream was here before. What we did earlier was to make the upstream branch progress here, and I'll just rebase the patches to be here. So let's do it. I go to my patches branch, and I say, OK, let's rebase it onto upstream. OK, I'm using bleeding edge Git. It seems to be broken. Now that's a bit. What happened? Yeah, I know. But I hard-coded the path to, well, not very pretty. Okay. What happened? Okay. My shell was supposed to get that, but okay, we're there. Okay, so the rebasing process is basically taking a pile of patch, storing them somewhere, and taking them one by one and applying them to the points as specified. Here, what we see, and it's expected, is that the third patch, it's said here, failed. And I'm not surprised because it's the patch where I reconfigure the source package to support K3BSD. Okay, so I know how to regenerate this patch. I don't really need Git for this one. I just auto-reconf. Okay. And when it's done, I say, OK, this patch is done, and I want to commit it. And I say git rebase -- continue to tell, OK, this patch is merged. Let's go to the next. Here will happen something really interesting. Git rebase says, OK, but there is nothing to commit. And the thing is, my upstream finally fixed its autoconf packaging. So in fact, I will have to drop this patch. It's not useful anymore. No problem. I say there is no patch anymore. And if we look at Git-K again, my patches are here. There are only 2 of them, and it's fully rebased. For this example, there wasn't any conflict. I didn't manage to generate simple ones, but Kilt would have done basically the same job. So it's not very brilliant as a demonstration, but I think you get the idea. Okay. Yeah.
So, how do you deal with bug fixes in the patch?
With?
When you version patch, and the patch and the bug fix for the patch. Do you just abandon the versioning that, or?
Well, I'll come to that, but as a matter of fact, I'm not really sure that remembering every state the upstream plus patches branch had is really interesting. You just want to remember a serialized version of it. And it's just what I do. I export that under Debian patches. I'll come to that. In fact, I generate something that is really near a killed series in the end. Okay, and finally, all my work, my packaging work, is done in a Debian branch. I do usually one branch per suite, one for Edge for backports, one for seeds, maybe one for experimental. And I merge upstreams directly in those branches. So it solves the problem I had when I package KDE. My upstreams is merged in my Debian branch, so I can experiment in it and do whatever I want. And then, what I just said, I serialize my patches under Debian patches, so that if someone comes and wants to enemu my package, he knows how to add a patch. It's trivial, just add one under Debian patches, and I'll take care of putting that in my Debian plus patches branch. So let's release Tokyo Cabinet. So now I go to my Debian seed branch. I say, OK, now I merge my new upstream. And now that I've done that, I want to refresh my patches. I don't really need that. OK. This thing, just use git commands. I can show you the snippets. Not really interesting, but it's somewhere here. OK, it's here. Git is able to generate a patch series really easily because it's how kernel developers exchange patches. So I just use that to generate my list of patches, and you can see it here. I have one patch per fix. And the patch system is actually really simple. It's just a matter of listing every patch and applying it. And that's done. Right now, I have a new. Let's see what it looks like. I have a new branch where I merged my new upstream, and I've refreshed my patches. Now, all the work I need to do is just Debian packaging. Okay. So now I'll come to the point where Git is really useful to me, not only in Debian packaging. What I really like is, I don't know how you work, but when I work, I'm really sloppy. I mean, my mind goes in every direction. I do many things at the same time. And I like to use Git like I save my buffer in my editor. So I commit a lot. And in the end, there is a lot of useless commits. And you can then use Git to simplify your history and to pretend you did a really awesome work from the first time. OK, I'll try to do something with Tokyo Cabinets. I didn't prepare this because I want it to be dirty. I'll try to remain, to not do that really. Well, I'll try to do that in 10 minutes. OK, so basically, Tokyo Cabinet is a really simple package. It's a library that is a DB-like library. And, well, I know for sure that this new library has a SNM bump. So I'll start with that. OK, not very clever. There was a stupid mistake. The DBG package doesn't need to have this name. I'll fix that. I'll fix that. Done. And that's done. Okay, so now I build my package. I'll spare you the test suites. Yeah, it should be cached, but okay, it's really fast to build. The point is, I will have errors because I forgot on purpose something. It's that I didn't rename my DH developers files, so it won't be able to install. I hope so. Okay, it didn't. So actually, I want to rename every file with a new name. And that is an example of a sloppy work. I mean, there is a state where my repository isn't buildable because these files weren't named properly. Well, and that's here, that Git is really helpful to me. When I'm done packaging Tokyo Cabinet, before pushing my branches and showing my work, I can pretend those two patches were one. That's how to do this. Once again, I use Git rebase. It's really an awesome tool. I say, okay, I want to rewrite interactively my two last patches. Let's do that. It spawns an editor to ask me what I want to do. And here is a really nice trick. You want to drop a package, really simple. You remove the line. Patch, of course. You want to reorder patches, really simple. You reorder the lines. You want to edit a patch because it sucks. You say, I want to edit it. And here, I want to merge two patches. So it's really simple. I say, this patch, I want to squash it on the previous one. And then I quit my editor, and it says, OK, here is a merge patch. That's a nice thing to show you what your patch is about. And it gives you here your two commit messages in the same buffer, and you can fix it. So, OK, prepare for a SNM bump. Because I'm clever, I did rename my developer files on the first run. OK, and if we look at the history again, almost, there is only one patch, and nobody will ever know that I needed to do two patches for that. Actually, my experience shows that if you use Git to commit a lot, it's really easy to do that work because your work will basically to be two operations, maybe three, dropping a few that that you don't really need, and most of the work is reorganizing lines and merging the ones that you should have done in one step. This work is really, really fast to do when you committed really frequently. What is really hard to do is to split a patch. Splitting a patch needs a lot of time because usually, well, there is two cases. Either you want to split a patch that touches really different paths. This is easy because you just unwind your patch and you recommit it into pieces. What is really harder is when your patch touches your same file and where that the chunks of the diffs are mixed. If you do that, it's really hard to split the patch because your sole option is basically to rewrite it from scratch. Whereas if you do incremental, really small commits, well, like I think you saw, my laptop here is running at 1 gigahertz because it's on power save. It was really, really fast to commit. Committing, unlike SVN, is really, really fast. I mean, most of the time I don't even notice it.